Instagram Live though.
No. I got my phone. It's only on 10%.
We can't. We'll figure it out one day.
We'll figure it out, though.
But this is Talkin Mush. And we're here with Larissa.
It's on you.
Is it on me?
Yes, sir.
Oh, look. We're here with Larissa.
Hello.
And I'm your host, Michael Johnson, and this is Colin Cummings. And Larissa, how do you want to be introduced? You're a neuroscientist. You study psilocybin. You study cannabis. What else? It's so exciting.
I mean, I study it all. I study neuroscience and the brain and a whole bunch of different things of the brain. Multisensory processing of the brain. That's what I study.
Awesome. And Larissa McKetton? How do you pronounce that? McKetton?
McKetton.
I got it right. I nailed it.
You got
Good job. Good job.
And you're going to be a resident scientist indefinitely.
That's the plan. I mean,
Yeah.
my title is scientist, so I'm a scientist.
Are the Talkin Mush resident scientist until?
Absolutely.
Absolutely. Awesome. And we're so excited to have you.
100%.
I'm happy to
Yeah.
be.
And thank you for coming.
What other podcast has an in-house scientist?
I don't know. I haven't seen it. I think
Zero.
Joe Rogan has a couple scientists, but it's like multiple.
When's the last time you seen
It's multiple.
one, though? I haven't seen Rhonda Patrick.
They just got
in
the
a while.
kooks now. They got the kooks on. They got the. It's hilarious. 5G, bro. Okay, so we have some questions for Larissa that we've prepared, and Larissa did some research for us.
Yes.
And we asked her these questions, and we came to these questions from interviewing all these other people, and just from our own curiosities, from our own experiences.
Yes.
And hey, Colin, why don't you take it away with the first one?
Oh man, the first question.
First one.
So I actually have these written down. I don't do this often when it comes to interviews, but when it's like solid stuff like this, I like to be a little prepared. So first question is, what happens in our brains when we take psilocybin?
So when you ingest magic mushrooms, the main psychoactive compound is called psilocybin. And once it's ingested orally, it gets absorbed by your liver into the active drug known as psilocin. And it undergoes this rapid dephosphorylation. So it just removes this sort of phosphate group. And
Let me stop you right there. Dephosphorylation. Can you tell me what that means?
Just a removal of a phosphate group. It's like PO4, 3. It's like a structure of the molecule that gets removed and gets converted into its active compound called psilocin. Then psilocin can make its way through your blood circulation into the brain, and it can pass the blood-brain barrier and then start its effects. So psilocybin cannot do this. Psilocin can, and then that's when its effects start to happen.
Can you tell us more about the blood-brain barrier?
There's.
How does that work? How do things cross it? What else can't cross it? Like, does it have to be a certain size or?
Certain size, certain ways it can pass through. It has to different types of molecules and different types of neurotransmitters can pass through and compounds, whereas others cannot. And there's selective permeability to certain compounds. So psilocin can, psilocybin cannot. And it's just this removal of this phosphate group allows it to pass through the blood-brain barrier.
Okay, and the removal of the phosphate groups is effectively making it like small enough to be able to cross the blood-brain barrier, or does it have nothing to do with size?
It has to do with size and other properties, but that's one of the main reasons why. So size and other properties that permits it to pass through the blood-brain barrier. And so then once it gets through, psilocin is very similar in molecular structure to serotonin. So psilocin can then bind to serotonin receptors. And there's about 14 of these serotonin receptors in the brain, in the mammalian brain. And the main one, the main subtype is called the 5-H2A receptor. And it's when psilocin binds to these serotonin 5-HT2A receptors, it causes this amplified stimulation. And that's actually what brings upon this increased sensory experience. So then the brain is led to perceive and experience things without a real stimulus, like known as a hallucination. And it's the effective binding to these receptor subtypes. And then once psilocin binds, you have these effects, and they start pretty much immediately within 20 minutes to 90 minutes. And the effects of psilocin last up to 12 hours. So, and it's also dependent on dose. But the effects that psilocybin have on the body and the mind and your experiences vary. But typically, people have their eyes dilate, their heart rates increase, the blood pressure in their body increase. Some people have these out of body experiences that they report. You have people that feel really relaxed. On the other hand, you have people that feel anxiety or agitation. There's more feelings of openness and imagination. There's a sense of loss of ego. And then you have people who have experienced synesthesia. So it's the blending of senses. And I can go into that a little bit more.
Right.
But another interesting point to mention is this warped sense of time. So people report feeling the slowed sense of time. Time appears more slower than usual. And there have been actually a number of studies that looked into this and that replicated this phenomenon where they had people who have taken psilocybin, tried to reproduce intervals, and they couldn't do them longer than 3 seconds, or where they were trying to synchronize finger tapping to auditory beats separated more than 2 seconds, they couldn't do it properly. So these 5-HT2A receptors, you can think of them having this like internal clock model for processing duration, discrimination, motor performance, and temporal control. And your just effect on the sense of time is warped. And that has been replicated in prior studies. But the main effect of psilocybin on the brain is varied because a number of studies show both increased activation and connectivity as well as decreased activation and connectivity. So I wanted to go over those areas of the brain that are affected by psilocybin a little bit more in detail.
Yeah, I'm wondering what the wide range of effectiveness is caused by.
Yeah.
Right. It's just one of those things where the brain gets both connected and disconnected in certain areas to elicit its response. So one of them is an increased activity in the visual cortex and sensory cortices that are related to sort of memory recall. So there was a study that looked at memory recall using fMRI. So fMRI, functional magnetic resonance imaging, is like a modality that looks at measuring blood flow, and it's linked to activity in the brain, neural activity in the brain. And they found that people who've taken psilocybin found there was an increased activity in these visual cortices during recollection of memories, and they had stronger memory vividness and visual imagery. And there was also a significant correlation between subject well-being at follow-up and memory vividness. So there's sort of this association with the structure of the brain and having this enhanced connectivity with an enhanced memory of vividness and visual imagery. That might actually play into the part of hallucinations down the road, but if you think about it, there's this one structure associated with it.
So that doesn't attribute to positive or negative outcome. It's just higher connectivity. Could mean anything, depending on what you experience, depending on your set and setting, I guess.
Yeah, and set and setting is very important, especially when taking psilocybin. But of course, so in this study, they did find increased activation in this region of the brain associated with memory recall. So there's this association with taking psilocybin. There's another region of the brain, or other regions of the brain showing enhanced activation, enhanced brain function, and this was used. This was done using a technique called PET, positron emission tomography, and it looks at glucose metabolism. So glucose metabolism is also a proxy for measuring enhanced brain function. And they found that psilocybin increases glucose metabolism in areas like the frontal cortex. And this was replicated in 2 studies. The first one, they used psilocybin concentrations between 10 to 20 milligrams. It was like an oral dose. They had 10 subjects. They gave them this oral dose, and then they did a PET scan after 90 minutes of dosing, and they found significant correlations between psychotic-like symptoms and increased glucose metabolism in the prefrontal cortex, so like your frontal lobe. Another study was replicated that they used a smaller dose, like a lower dose, 0.2 milligrams, and they waited 150 minutes after dosing, and they also found increased glucose metabolism in the frontal lobe, the temporal lobe, anterior cingulate cortex, so cortical like regions, and also decreased glucose metabolism in the thalamus. So the thalamus is a brain structure. Thalamus. It's a brain structure. It's like a subcortical structure. It's it's like a sensory information relay station. And there was decreased activation. note that this study was done in the 90s, and they were taking their measurements after like 90 minutes, 115 minutes. So there was this time delay, and it could play a part to why we see this increased activation, whereas other studies found decreased activation in other areas. But that's the next point I wanted to mention. So a lot of studies now have found decreased blood flow and MRI signal after taking psilocybin in very important regions, and this region is called the default mode network. So this network, I'm not sure if you've heard of it, but you have. Okay, so like this network is, which involves the thalamus, this region of the brain called the posterior cingulate cortex, and the medial prefrontal cortex. So this is like a network of the brain, and it becomes active when people allow their minds to wander. So when you're at rest, the default mode network is activated. And it's crucial for introspective thought and for generating the sense of consciousness.
Like when you're dreaming?
When you're at rest. So just lying down, letting your mind wander, that's your default mode network.
So daydreaming.
Daydreaming. Well, essentially. And that default mode network is crucial for like I said, introspection, sense of consciousness. And psilocybin reduces the neural firing in key communication hubs of the default mode network. And it essentially disconnects some brain regions from each other. So you can think of the decreased network of the default mode that drives the experience of someone to have the sense of ego loss after psilocybin use.
Okay. Can you go over that again?
Okay. So when you
driving the sense of ego loss, what is happening there?
So like I mentioned, the default mode network, it's the sense of ego, the sense of consciousness, introspection, your thought process.
Yeah.
That decreases after taking psilocybin. So
right.
The default mode. So now you might experience ego loss after psilocybin use because this network is now disconnected. And
interesting.
So what's more interesting is people who had like a lot of decreased activity, the most inhibition in this default mode network, reported more intense hallucinations or hallucinatory experiences.
Right.
There's
so
like direct correlation in this structure.
So it almost is a disconnection from self, the default mode network.
Yeah. And you know what's interesting? Another thing that you can do that decreases the default mode network activity? It's meditation. So
okay.
when you meditate, your default mode network dampens, the activity in the default mode network dampens. So it's really nice to see this interplay between meditation and psilocybin use in the structure of the brain, or this network of the brain.
That's very interesting, actually.
Jeez. I'm so excited about this. So much information.
Colin's gonna have to watch this again.
Exactly. Because as soon as I heard that, because I don't have intense hallucinations, so it's making me think about my default mode. So it's not dampened enough, I guess. Because I never completely disconnect from self. So more meditation, I guess.
Yeah, quiet that mind.
Yeah.
Have you seen comparisons between like people who meditate and people who take psilocybin and like the effectiveness of this phenomena?
I think there's a study on that. I might get to it. I have to double check, but I'm sure it's probably an additive effect.
We'll be sure to have you back to find out more.
But there's more things that psilocybin does to your brain. So
okay,
I'm not finished.
Tell us more.
So you know the term brain plasticity? Okay, so psilocybin is known to.
Well, let's explain for our viewers brain plasticity, how the brain can
rearrange itself and is dynamic. The viewpoint, the paradigm a while ago was your brain was static and the neurons you have are like
how long ago?
Not changing. Oh God, that shift.
When did that view change? When did that view become plastic?
I feel like 12 years ago, 15 years ago.
No.
That's when I started hearing about it.
It's been decades of research, but there was a moment where it was like the 40s. I have to double check that, but where the mind was thought that it was static. You cannot change it through anything else. But we now know that there are so many things like epigenetics and other things you can do that change the mind. So another thing that psilocybin does is sort of temporarily rearrange itself by inhibiting, like I said, normal brain activity, but it can cause new biological stable brain connections to form. So So you can think of it this way, like psilocybin and other psychedelics, not only psilocybin, but it drives information to underused pathways, and it opens up different routes, and it frees up space along more heavily used pathways. So if you have someone going in, like say an MRI scan under resting state, so they're just lying there. There was a study where they injected these people with 2 milligrams of psilocybin on 2 separate occasions, and they found that there was a dramatic functional network change where more of these regions of the brain were interconnected or intercommunicating with one another. So there was this crosstalk. So this was that image where you saw connections being like the placebo, and then hyperconnections being formed under psilocybin.
Right.
So you can think that psilocybin effectively sprouts new connections across areas that were disconnected before, and then it temporarily alters like the organizational framework of your mind, of your brain, and it's this crosstalk, and it makes it really harder for people to discern fantasy from reality. And
let's see if our desktop view works. Nope, doesn't work. Not today. We're going to show the picture of the image that you referenced.
Okay. Well, for the next podcast,
we'll fix it.
We can touch base on that. But that sort of explains why people report synesthesia and this crosstalk. It's because there's this disconnection, but also this enhanced connection being formed. So there's a number of things that are happening in the brain.
You mentioned synesthesia. That's like
it's the blending of senses.
The blending of senses. So people are experiencing that because of this heightened connectivity in the brain.
Correct. So that could be like people that report tasting shapes or hearing colors, or just the blend, all the different ways you can connect the two. They have these reported affect. So synesthesia. Taste
the rainbow.
Yeah, taste the rainbow essentially. So those are many ways where the brain is affected by psilocybin. So just to summarize, there's activation, there's stronger connectivity in some regions, and there's deactivation in others. And it's sort of this nice interplay between the two that allows for the effects of psilocybin to happen.
Very cool. Well, hey, you know what we didn't do? We didn't hit the Larissa intro. So
while she was talking, I realized.
Let's do it.
You want to do it now?
Hit it. Larissa McKetton on Talkin Mush. No, that's not it. Yeah. We're good.
There we
go. We're back. So good. We'll get the hang of that one day.
That was really good.
Yeah, let's ask is there any other ways that psilocybin changes the brain that you want to tell us about?
Well, there are other image modalities that sort of replicate these studies. Mm-hmm. So like when I talked about decreased activation in the default mode network via functional MRI, there's other studies that replicate it using different modalities. So I don't know if you've ever heard of MEG.
MEG?
MEG. Magnetoencephalography. It's another neuroimaging modality, and it looks at how like neurons and clusters of neurons.
Is that like an MRI, but different?
Different. It's different. It measures like the neuromagnetic signals generated by the brain. It's a different modality, but basically they replicate it in a different modality, showing how there's desynchronization in that structure of the default mode network, posterior cingulate cortex. And so it's interesting when you're reading all these studies, how different studies and different modalities are finding the same things. So it's nice to replicate that. So that study found that psilocybin induces large decreases in oscillatory power areas of the default mode network. So there's desynchronization of the default mode of the posterior cingulate cortex. So it's that's just another study that sort of replicates the others.
Right on.
Yeah.
Very cool. Well, Colin, will you do us
man.
the honors of asking the second question?
It really feels like Dr. Rhonda Patrick. Like my brain starts to heat up. I'm like, oh man, so much. How does she know so much? So the next question. This is something I've always been curious about. Just because since I've learned what serotonin is and feeling like it's drained. Oh, Colin button. Hello guys. Is psilocybin draining our serotonin at all? And if so, like we talked about when we talked about 5-THP, does that help replenish it? Does that bring us back to normal?
Okay. So the short answer is no, it does not drain your serotonin. But before I go to that answer, I want to sort of describe what 5-HTP is for your listeners in case they might not know.
Please.
So 5-HTP, okay, it's like an acronym for something called 5-hydroxytryptophan, okay? I know it's a very big name, but it's just an amino acid and a precursor to serotonin. So it's something that becomes serotonin. So when you take 5-HTP, you can buy it at any health food store. It gets converted into serotonin via enzymes like utilizing vitamins like vitamin B2, B3, B6, magnesium, zinc in the body. So it gets converted into serotonin, and then it gets converted into melatonin, which helps you sleep. So 5-HTP to serotonin, serotonin to melatonin. So it enhances serotonin production in the body, which helps people who have serotonin deficiency. And it also helps regulate like appetite, your sleep, and helps with anxiety and your mood regulation. So sort of like this all-encompassing great thing to do.
Right.
But unlike MDMA, I can talk about MDMA, psilocybin does not flood or drain the brain with serotonin. It doesn't drain it. So as mentioned before, like how the molecular pathway of psilocybin, it targets the subtypes of serotonin receptors, it binds to these serotonin receptors, the 5-HT2A primarily, and it activates them, but it doesn't drain the serotonin out of your neurons or your cells. So 5-HT2A receptors are known to help with regulating mood, anxiety, schizophrenia, and consciousness. But in this way, psilocybin doesn't deplete serotonin out of your neuron, causing a depletion. Now, I mean, that could be studied further, but evidence does not show this at this moment. But MDMA is a different beast. Okay, right. So like MDMA works totally different. MDMA like enters the neuron. It enters your neuron and it uses something called the serotonin transporter to enter the neuron and binds to that. And then once it's inside the neuron, I know it's many things happen, but it inhibits something called VMAT2. It's like a vesicular transporter. It's something else. So it inhibits that. And what that means is serotonin is not neatly packed into these things called like vesicles anymore. And it accumulates within the cell. It's called the cytosol. Like imagine like the fluid of the cell. It accumulates within the neuron. But then MDMA releases serotonin into the synaptic cleft. And it denies its reuptake. So I don't know if you've ever heard of like antidepressants, SSRIs, serotonin reuptake inhibitors.
We're gonna have to get a whiteboard behind you next time.
That's okay. I can like draw
Let's get it. Go get the whiteboard. We know you have one.
So basically, MDMA is like affects serotonin, and it like makes it such that it's not in the neuron anymore. It's in the synaptic cleft. And it makes the receptors on the postsynaptic membrane go like crazy, like haywire for a few hours.
Right on.
So what that means overall, serotonin is depleted from the neuron, and that's that depletion that is needed, like the 5-HTP, or there needs to be something that can help recover after taking MDMA.
So 5-HTP helps recover it.
Well, 5-HTP helps convert. It's a precursor for serotonin, so it helps create serotonin because it's been depleted in the neuron.
Right, I understand.
But also
it leads
MDMA,
to it.
Yeah, but also MDMA increases dopamine and norepinephrine, and that's the reason why it gives the ecstasy properties of it. But so MDMA depletes serotonin from the neurons, whereas psilocybin doesn't act through a different molecular pathway.
Right.
So
how does that work?
It binds through, like I mentioned before, it binds on the 5-HT2A receptors. It binds them directly, so it doesn't affect the serotonin within the neuron. It doesn't deplete the neuron of serotonin.
Wow. Okay. So, just quickly to MDMA, is that damage permanent at all?
I would have to look at long-term effects of MDMA. I've looked at long-term effects of ayahuasca and noted there were differences in cortical thickness in certain brain regions.
Okay.
MDMA, I would have to double check and get back to you, but I'm assuming with serotonin depletion, there might be areas that are affected of the brain and certain long-term effects, just because it has more of a effect already seen in this molecular pathway, where psilocybin does not.
Man, I'm just asking questions for myself. I'm just making sure I'm not messed up for life. I have a couple of dozens of nights.
So psilocybin attaches to a different receptor, which basically results in not draining the serotonin. You're saying no?
Psilocybin attaches
Clarifying.
to the serotonin receptors,
Yes.
and then it binds to them, and then it causes them to create the response. Whereas MDMA acts differently. It actually can affect by going into the neuron, thereby releasing serotonin out and causing a depletion of serotonin within the neuron. And that is why you would want to take something like 5-HTP to
So it's connecting with instead of going inside of.
It's just a different pathway. They both affect the serotonergic system, but MDMA, in addition, increases dopamine and norepinephrine, noradrenaline levels.
Okay.
So there's this additional pathway, but in addition, it also depletes serotonin from your neurons. So there are sort of two different pathways. Both affect the serotonergic system, but differently. It's very clever. MDMA is very clever.
Yeah, that's my first thought when I take MDMA.
Awesome.
What a clever thing this is.
So people around the world who take psilocybin, they tend to report similar experiences, the same types of visions or the same types of like sort of takeaways. How do you explain this? How does science explain this, rather?
So that's a great question. The short answer could be, and it's just assumption, where a person is having these similar hallucinations or similar experiences based on the set and setting, and they're familiar with the surroundings that could influence a repeated hallucination. But that's sort of in a nutshell. But if you want it to be,
so you're saying like if set and setting is curated in a certain fashion, like a certain ritual, then people are more likely to experience the same
repeated hallucination, or it could be influenced the same type of hallucination.
So people following the same type of ritual worldwide will that might lead to that. Okay.
However, that does not explain scientifically what's going on. And to answer that question scientifically of like what's going on, how does a hallucination get created in the brain? You have to look at like mouse studies and look at neurons and firing and how they're activated when they're given a hallucinogenic. So there has been a study in mice. So it's kind of like so this answer is kind of like answering it based on a mouse study that we can infer from it.
Yeah, but it's less of a I've heard it's less of a hallucination. Like you don't really hallucinate. Like you're not going to see magical beings appear in front of you, or you're not going to see like your couch morph into, you know, a cup of wine or something. You're not going to see like some crazy things, but you'll see like a breathing of patterns, or you'll see but more people experience the same. It's like feelings, almost like the feelings of love, or like the oneness with nature, or that ego death, like these similar experiences. It's less what you see, it's more how you're feeling it, which is more similar. Right. I've heard a lot of people say that they don't hallucinate on mushrooms. Specifically, that psilocybin isn't a hallucinogen. It's kind of misclassified. Don't quote me on that.
I was right up there with you. I remember the first times that we ever tried it, I would be like, nah, I didn't see anything, nothing moved, like nothing. It took years, like almost 3 years.
Well, what do you mean it took? So then when you said you see things, like you mean like breathing, like you'll see
like breathing,
patterns will move, but you're not going to see like a gnome appear and it'll come out of your wall and be like, hey, Colin, going, buddy.
Yeah, exactly. No. I would agree with those people until I saw like a little bit, but yeah. No real physical hallucinations.
Anyways, go on.
Okay. So what I was saying was there was this actually a really amazing mouse study done where they gave them this hallucinogenic drug, and they wanted to see the response of neurons. Like they used electrodes to measure them, and they found that when they were given these mice the hallucinogenic, they put them in front of a computer screen and showed them simple geometric patterns like horizontal or vertical lines. And then they wanted to measure the electrical response that these neurons are firing. And what they found was there was a reduction in signal strength of these neurons, and there was this unusual and wonky timing of neuronal response in the primary visual cortex. So we're having a difference at the neuronal level. So we can't do this like in humans right now, right? But like we can infer based on mice what's going on. But then what was very interesting was that these mice that were previously trained to recognize the horizontal and vertical lines, had then showed stronger neural effects from the drugs. And this finding could indicate that being familiar with a stimulus could influence how the hallucination acts. So
Okay.
does that make sense?
Being familiar with the stimulus can affect how the hallucination acts.
Yeah, because they found that the mice that were trained on viewing these vertical and horizontal lines after administering them this psychedelic drug, they had a stronger neural effect. And that finding they're suggesting is now this can influence how the hallucination behaves, because they have a familiar response to the visual cue that they were provided.
So setting has a very strong impact on your hallucinogenic experience.
Yeah. So, and this was a very simple study, but that was like a finding, an ancillary finding that they didn't expect. But there's some problems with the study. You can't ask a mouse if it's hallucinating or not. You're just basing it on how neurons are firing, but you do, and you can measure activation and decreases, increases, and the timing, and you can inference on that. But at a like a neuronal level, you do see differences and you do see different patterns, and it could help explain why people have these types of hallucinations that might be repeated.
Man, mice brains must be unique. But have you seen that episode of The Portal where they talk about lab mice telomeres and how the way they were bred was they were bred in a way that lengthened their telomeres so that it messed with the length of their life. So basically, all lab studies ever are kind of botched because you're not getting accurate, the right type of mice. Basically, you're getting these mice that are bred specifically. Don't quote me on this, but it's a huge finding that
makes sense.
These guys are trying to talk about on The Portal. It's a very interesting story. It involves the Nobel Prize winner who's trying to cover it up and all this crazy stuff. So if that's true, though, like all the drugs that were derived from these tests that use lab mice are gonna have to be redone. Imagine all that data being thrown out.
Jeez.
But anyways, I digress.
That's pretty big. I've never heard that.
Yeah, I wanted to even say that just to get it out there more, because Eric's trying to talk about it. Eric Weinstein is trying to. It was his brother's work, and he's trying to get it out there. So it's like super interesting. Anyways,
wow,
Larissa, you have to watch that episode. I'll show you. Your mind will explode. So.
So set and setting. So that makes a lot of sense, because a lot of people, when they do like ayahuasca and they have like the classic experience of going over there, a lot of people report seeing jaguars,
yeah,
and different types of animals there. They report seeing them, even though like not actually, but like they hallucinate that they see them.
I wonder also if it's expectation too. If you're like in a place where you see a lot of trees and you think you're going to have this sort of mystical experience and you associate it with those things,
yeah,
it could help or it could contribute to your hallucination.
Maybe, because like when I did it, I wasn't in a jungle, I was just like in a regular place, and I didn't see anything like that. But so many people report seeing that when they do ayahuasca. That's so interesting, man. There's so much. Was that the fourth question that you just asked?
I'm doing it.
Oh, you're going now? Sorry, I thought that was that.
Why do psychedelics have the potential to change your mind? So like alleviating depression, or smokers quitting, or alcoholics getting over their alcoholism, or even helping with like eating disorders.
So that's a great question, and there's a lot of literature and body of work on it. And just even recently, there's 3 placebo-controlled trials on psilocybin for anxiety and depression.
Were those double-blind studies, or?
Yeah, related to end-of-life diagnoses, and like all show positive findings. And now there's actually companies that are being set up to look at psilocybin in clinic. So there's multi-center dose finding studies that want to look at psilocybin specifically with depression and try to alleviate it. But it's not only depression, it's also alcoholism, tobacco. So it helps with addiction, and it helps with internalizing disorders like anorexia, obsessive compulsive disorder, chronic pain, opioid use disorder. So psychedelics seem to work and have a common theme. If you think about it, these internalizing disorders are all intertwined. It's this mindset, this
I was going to say mindset, perspective,
where patients continually ruminate over their feelings. So with depression, they keep reiterating thoughts of guilt and engage in self-critical inner narrative. So it's like this inner self-dialogue that is destructive. In addictions, the object of addiction is to take on the role of negative thinking, like in depression. And it's this negative feedback loop that's part of this rumination that's problematic. And it's shown, so with depression, internalizing disorder, you have something like anorexia, where you're always thinking about managing calories. And then you have something like OCD, you're always managing, like, everything is contaminated. So it's like this feedback loop that is destructive.
This cyclical way of thinking.
Correct. So psychedelics have a way by dysregulating activity in these systems, specifically with internalizing disorders.
This is huge.
So what they do is these circuits that encode this habit of thought and behavior, psychedelics do like hard reset, and they allow the brain to recalibrate it's a temporary effect, it's acute effect as the drug subsides, but there are long-term lasting effects. Like you can see after psilocybin use, depression improves, cessation of smoking, all these other things improve through time. It doesn't have to be a constant thing. So there is a long-term effect as well. But it's a reset of this internal rumination and dialogue that all these conditions sort of all interplay together. If you really think about it, they all are interconnected.
Yeah, that almost speaks to like people having like an ego death. Like we're all in this big cyclical thing that is life, and getting up into who we are as people, and we that's kind of like a macro picture of cyclical thinking, even though it's the right way to be. And so like when you have an ego death, you're being disconnected from your entire way of being for a moment to be able to sort of recalibrate and come back to that. That's really interesting. I think I've never heard that before, that all these like these illnesses and ways of mental, they all have something in common, one thread that goes through them all. And it's amazing that psychedelics that you've been able to explain how psychedelics sort of disrupts that pattern, and it kind of explains why it can help all these different people. So it makes me think, it's not on the question list, but it makes me think about why people with schizophrenia end up being triggered by psychedelics instead of how is schizophrenia different than all of these other
conditions, like mental health conditions that have underlying disorders, so like schizophrenia and other mental health issues, psychedelics, like even like in cannabis and other compounds, can actually exacerbate its effects. And a big answer, one of the main answers, is the 5-HT2A receptors and their function, because they're also involved in schizophrenia. And so in the schizophrenic brain, they already have differences that once you induce something like psilocybin, which affects these receptors, it could uncover other mental health issues and actually exacerbate them or enhance them in a negative way. And that was another question. It's like, what are long-term effects, or what are some negative things with psilocybin use? We can touch base on that, but in terms of long-term effects, people also report something called like hallucinogen persistent perception disorder. I don't know if you've ever heard of this. It's HPPD. So it rings a bell. It's like it refers to like flashbacks.
Okay.
So it's a condition unique to psychedelics, and it involves like perceptual changes, and it can last like weeks to months following the use of psilocybin.
Right.
And research also found that psilocybin can produce psychosis, like a psychosis-like syndrome, and it mirrors early episodes of schizophrenia. But more research is needed to disentangle that and answer that, because we know that psilocybin may trigger and exacerbate mental health conditions, and like the mania, depression. We just need more research on that, because it's still pretty rare, but it does happen in people, and it's usually people that have underlying conditions that might happen later on in life, that when you take these drugs might have them come out earlier. than expected. And it has to do with the interplay of the 5-HT2A receptors, because they are involved in schizophrenia as well, in consciousness. So it's all interconnected.
Very interesting.
That's nuts.
Mm-hmm.
Wow. And you know what? I don't know. I have heard of that. What did you say? HPPP?
HPPD, hallucinogen persisting perception disorder. So it's mistakenly referred to as flashbacks, but like it's common. Well, no, it's not common, but it's rare. But people have these flashbacks that are like these are like long-term effects after psilocybin use, and it's still pretty rare, but needs to be further studied.
Like flashbacks in the sense of they go right back to that state, or is it like very minimal? Like
it's involving perceptual changes. So it's like they might experience the way they felt when they were taking psilocybin. So they might have like that feeling re-enter their body, and like you start to feel the way you felt when you took psilocybin, and you might have these perceptual changes. So if you hallucinated when you were taking it, and then say weeks or months later, you start to have that same hallucination without taking any psychedelics, it could be related to this HPPD.
Wow, I've had that, definitely. Have you like I'm asking you, have you ever like taken psilocybin at some point and like seen something move and then like not been on it like a day or two later, and then look at it and see it move a little bit?
Yeah, there's definitely like effects that last after the trip.
Is that like that? Is that or is that something different? I don't know.
Yeah, how do you explain the longer lasting? Like you take psilocybin and the effects last after the trip. Are you able to speak to that at all, or is that a question for another day?
Are you talking about like if you take psilocybin and then weeks later you start to have the same perceptual changes or the same hallucinations?
No, more like a couple days after you're still feeling a bit light on your toes, or like you might catch a pattern doing a little bit of a wiggle out of the corner of your eye.
Could be just the wear down, because they measure this effects, and it's up to 12 hours. So I mean, there are long-term effects, and maybe residual effects is something common or based on anecdotal observations, but it could just be I mean, everybody acts differently. So when they talk about starting any type of therapy, whether it's psychedelic or not, it's to go slow, start low and go slow. So people react differently to a number of different things. So, I mean, you don't want to take like 25 milligrams of something like right away.
You can never be too sure. Yeah.
No. So, I mean, people react differently, and the duration can affect you. So it could just be that it's still dissipating from your body.
There's a study they did on people with depression, and they give them psilocybin, and then like a year and a half later, they interview these people, and they're still feeling the effects of like changed perspective in life, and they're happy, and their families get interviewed, and their families are like, what did you do to this person? They're so happy now.
So there's a lot of depression, like studies on depression, and there's like anecdotes, and they interview people, and a lot of them just say they had one trip, one experience, and that was it. They didn't
just one,
anymore. Just one, and it makes for kinder people. They feel happier. Depression symptoms went away. Like I said, it's a hard reset, and some people it affects them differently than others. But there is proof to the pudding. So I mean,
well, they say the psychedelic experience is kind of like having a child, and some people stop at one, and some people have more.
And some people have none.
Is perfect.
Yeah,
that is a good analogy. That is really good. Wow, I get that completely. Maybe there's a correlation, because I
just blew Colin's mind.
I want to have a bunch of kids, and I also do psilocybin a bunch.
There you go.
Isn't that weird?
Well, you haven't had one yet, so you don't know what the experience is like.
Start with one and see how that goes.
And start with like Larissa said, you start slow. People sometimes have twins, or who's the octa mom?
Yeah, exactly.
That's like doing 7 grams.
Yeah, exactly. right. That's like what Mel did. She just like took 10 grams right away.
Is someone that took it for the first time?
Yeah.
Oh.
There wasn't a ski, or like they didn't have a scale or anything, and she just kind of just took what she took. And
one of our previous guests.
Yeah, and she realized after how much it was.
This lady with her family.
Yes, like a middle-aged older lady, very open. Had a nice experience with her son and her husband.
Yeah,
amazing.
Took too many, but it went well.
Yeah.
Well, Larissa, thank you so much for coming on Talking Mush and sharing all that with us. That was beautiful.
Thank you for having me, and I'm
Yeah.
happy to be on and talk more. There's
Thank
so
you
much more I want to talk about.
Yeah, we'd love to have you back to talk more and give us some facts. I think you filled us up for today, though. Is there
Okay.
anything you wanna plug? Any social medias? Anything you're up to that you want to share with us? That's up and coming.
Next time.
Next time,
Wow, I like that. She came just for the cause.
Larissa has projects in the works.
That's
She's going to
so
share them
many.
with us
Yeah.
later.
That's amazing. But thank you so much for this. This is like something that I always want to do in my spare time, and I never get around to it. So to have somebody actually hit the hard facts and do it so well is a pleasure. Thank you,
Yeah.
thank you.
Yes, we're widening our knowledge, and
I'm
that's part of
happy
why
to
we're
be
here.
here.
And if you want to see more episodes of Talkin' Mush, check out talkinmush.com, or check out live episodes at twitch.tv/UnrealJohnson.
True.
That's JONSSON, in case you can't find it. And please leave a review and a rating for this podcast where you consumed it. Those reviews and ratings help people find the community and get involved in these types of conversations. And thank you very much. We appreciate you, and we'll see you next time.
And when you see this on YouTube, please like and subscribe.
Hit the Larissa out button.
Larissa, it's been fun.
Talkin'
Thank
Mush.
you. Thank you so much.